For this problem, we have a hook that has a 12 millimeter curve at the bottom, and it is subjected to a 60 Newton force acting downwards as shown in our diagram. And we are tasked with determining all of the internal forces and moments at this cross-section AA. So the first step for tackling this problem is drawing a free body diagram. So since our location of interest is at this plane AA, we're only going to draw the bottom half of the hook, and we want to focus specifically at this plane here. So this is where our plane AA is. So in this free body diagram of the bottom of our hook, we have our givens, so our 60 Newton force acting downwards, and this of course is 12 millimeters away from the center, which is our radius of our hook. And then we are also going to have at our AA plane, we'll call it point A, we'll have a force at A in the Y direction, we'll have a force at A in the X direction, and of course we're going to have a moment about point A. So in order to solve for these internal forces and moments, we're going to use our equilibrium equations. So first we can start with summing our forces in the Y direction. And in the Y direction, we have our FAY acting upwards. We have our given 60 Newton force, so we use negative 60 acting downwards, and this is all equal to 0. Summing the forces in the X direction, we have just our FAX, and that is going to be equal to 0. And then summing our moments, we have our MA, and then we're going to subtract our 60 Newton force that is acting 12 millimeters away from our point of interest. So that's going to be 60 minus 60 times 0.012 meters. And again, this is all equal to 0. So now that we've set up our equilibrium equations, we can rearrange them to solve for our unknowns. So now we know that our FAY, rearranging this equation, is equal to 60 newtons. Our FAX is equal to 0 newtons. And our moment about A is going to be equal to 0.72 Newton meters. So now we can go back to our diagram and draw our final solution. So our FAY is going to be equal to 60 newtons. Our FAX is going to be equal to 0 newtons. And our moment about A is going to be equal to 0.72 Newton meters. And cleaning that up so we can see it better, we have our 60 here, and our moment, which is 0.72 Newton meters. And that is our final solution.